I guess we can start. Welcome back, everyone. So Tuesdays will always be days where I pass back quizzes. So usually it may not start right at the minute, but I have to make sure I get everyone's quiz back. And essentially the way you turned in your quiz is also going to dictate how you get it back. You're always welcome to turn them in digitally. You're welcome to turn them in as hard copies. I encourage you to just go with whichever way is the most convenient. But keep in mind, if you want your hard copies back, I only return them if you gave me a hard copy. If you emailed me your quiz, I'm going to email the graded version of that quiz right back to your email address. So you may have to print them out if you want those hard copies. So that's essentially how all the quizzes will run. And each time I do grade your quizzes, before I even email them back, I'm always going to go up into, let's see here, top of the Moodle website. I'll go into grades and just import your grade. That's going to be a great place to always check out. And after this week, I'll have more information. Due dates are going by in WebAssign. So I'm going to be adding a WebAssign grade so you can have a one-stop shop to check out everything. And also be posting a course total, which is how you're doing this semester at the end of that week. You'll see that appearing probably Thursday or maybe around Friday this coming week. So that's how all of our quizzes are going to run. And again, I encourage you to always double check your grades, not just for this class, but really for all of your classes. Mistakes happen, and if you catch it early, that's always the best time. I'd always double check that everything got inputted correctly. Well, currently we're way down here, section 2.1. But any questions at the moment with the quiz? Okay, well, oh, sorry, go ahead. It is a one try, yeah. But what we'll be doing at the end of the semester is we are going to drop the lowest 3 quiz grades. And then I mentioned we'll be having an extra credit opportunity, which could bump that to dropping 4 quiz grades. So at the end of the day, folks' quiz score is usually quite high for participating in the course. Other questions at the moment? Okay, and occasionally some of these quizzes are not so bad. Sometimes they might be a little bit more trickier than others. And so once I hand back quizzes, one thing that's always on the table is you're always allowed to ask questions about the quiz. So I'll leave it up to the class. Did you have any questions on your returned quiz that you'd like to discuss? Okay, I guess I personally did have one question that I want to discuss on it. So let's maybe make that our first thing we do today. Let me open this up. I'll open up the PDF version just since it's easier to draw on here. And the one I want to take a look at was pretty much part A here. The quiz wasn't terrible, but I think part A was the trickiest one. So let's take a look. It says, in this problem, is this an example of an observational study or an experiment? Now, these questions are tricky because they come directly out of the definitions. So sometimes it's kind of more of a how much we want to put into researching the question. Once you've noticed that you found these 2 buzzwords, observational study, experiment, one thing you can do is just leave this quiz right here, go to the Moodle website, and check out some of these sections. Really, this is meant to be one big resource. You could do the same in your book. If it's a digital version you're looking through, you could even search those terms. That's really pretty helpful. We opened up, say, 1.2, then just keep scrolling until those terms do come up. So here's those 2 core definitions that part A was asking about. It says here, an observational study is a study in which the person conducting the study observes characteristics of a sample selected from one or more existing populations. And it gives an extra information on what the purpose and goal is. But when we go to read an experiment, I would say this portion highlighted is a great way to tell the difference between the 2. In a real experiment, the person carrying out the study determines who will be in each experimental group. Already there has to be more than one experimental group, usually a treatment group, and the other one might be, say, a control, and what the experimental conditions will be. So with that in mind, back to the quiz, I'll leave up to the class. What would you say this ought to be, an observational study or an experiment? Yeah, go ahead. Exactly. Everybody, all 36 participants, they all got the ginkgo biloba, and then they had their test taken on the memory test. But there was no control group. There was no random assignment, and that alone makes it observational. Exactly. Yes, question over here.
Well, I was going to say, one of the control group is the general population.
It couldn't be the general population because they would have to have been joining these participants in the study themselves. So they would have to be with the participants. They are probably going to be given a placebo that doesn't even have ginkgo biloba in it, just a sugar pill or something like that. And then they have to take the memory test along with the participants as well. So an experiment means, say the 36, half of them would take the real ginkgo biloba, whatever that is. The other half, the other 18, would take just a sugar pill. Probably no one would know which one they're getting. And then at the end, they would all take the test and they would compare the scores between the two groups. For ginkgo biloba to be considered effective for your memory, it has to beat the placebo. And like this was saying, these effects are not well supported by well-controlled research. And you can almost see why. This wasn't well-controlled research. It was still a study, but we can't say ginkgo biloba caused an increase in the memory score. We can just see what happened. Their average was 84 points. So to me, that's the trickiest question on right there in part A. Well, any other questions or discussion folks would have about quiz 1? Yeah, go ahead.
No matter what, or sorry, is it an experiment, no matter what, control group?
Yes, we have to have some kind of baseline for comparison. I wouldn't say necessarily one group is a control group, but maybe the more ironclad condition is there is more than one group. We may consider treatment 1, treatment 2. There may not be a control, which would be highly unusual, but there might be certain studies where that is appropriate. But there has to be more than one treatment. Does that make sense with that question there? Gotcha. And then very, very often there's a control group. Other questions or comments? Okay, well, we'll get in a pattern of kind of doing this after every quiz that we've handed back. I'll solicit questions. I'll usually try to pick a question that I felt like was the trickiest. We'll discuss it as a class. If I feel that everyone just kind of nailed it, I might just ask questions and then we'll move on if there are none. Well, any last questions or comments before we close out quiz 1? Okay, let's turn this off right here. And as far as reminders about these quizzes, I think I've mentioned this 2 or 3 times already, but let's mention it one more time. It's a very good idea to keep these quizzes in a well-organized folder. Say, if you're getting them digitally, just put them in a folder on your desktop somewhere. If you're getting hard copies returned back, then definitely have a nice spot for them. Since these are really good questions for reviewing on exam 1, the final exam as well, when I write the quiz, I try to write a question that would be considered a real exam question. So even though this one isn't going to be on the exam, you can almost expect something similar, just a different study, different scenario. And this is just, again, another resource for studying. Well, that was a lot of announcements, a lot of discussion. Let me now go back to let us all go back to section 2.1. Any questions at all then, folks, before we jump back in? Okay, so we're running through chapter 2. When you're doing your reading, you can read all the way up to section 2.4, but I would encourage you to leave it off for the moment. 2.4 is a little bit special. If we go just for a moment up to the syllabus, here's my day-by-day syllabus. And section 2.4, I've left it right after exam 1, only because the topics in 2.4 are essentially exactly what you're about to do in section 4.1. So I felt like it'd be a better idea just to leave it for right then and there, around the 25th of September. So we're going to finish off chapter 2 in pretty quick order, leaving 2.4 for later. So now finally, let's see where we left off. So here's our section 2.1. We're leaving off right on example 3. We mentioned there's 2 different kinds of data that we're interested in. Categorical data, that's when your responses are just placing people into categories based off features. Maybe short people versus tall people, maybe the program you're in, say statistics versus chemistry versus nursing and so on. Numeric data are data where taking averages would make sense. They could be the result of measurement, the length of something, amount of time it takes to complete a task, or just say the number of items a certain person might have after, say, going shopping. I think that was one of our examples. But based off these two types of data, when we go to display them, here's the kind of displays we're going to focus on: the bar chart for categorical, histograms, and a couple others if it's numeric. So that makes example 3 ready to go. Oh, sorry, question first. Yeah, absolutely. Histograms are kind of tricky since anytime we deal with a histogram, it looks like a bar chart, but actually is not a bar chart whatsoever. So let me see if I have a quick one I can pull up. Maybe nothing inside here, but I bet you have a histogram somewhere. Let's go to section 2.3. Oh, that was the histogram we looked at before. How about we do a slightly different one? Let's take a look at this histogram for the moment. We're going to come back to this problem, but think of it kind of as a preview. So we need to take a look at the context first. It says, beginning in 2017, public companies will be required to disclose the ratio of CEO pay, Chief Executive Officer, to the median worker pay. This was a wonderful law, and if you've ever been to the Glassdoor website, they're a big fan of it as well. It gives you a lot of disclosure on just how much people are actually being paid. So when it says median worker pay, that's the person right in the middle, the 50th percentile person. Half of everyone gets paid less than the median worker, and half of everyone gets paid more. So now here's our histogram. Let's take a look at what the scenario is. It says on this histogram, a ratio of 1 indicates that the company CEO makes the same pay as the median worker pay. So your chief executive officer is getting the same rate as your typical person on the books. That sounds unusual, right? Usually the CEO is paid a lot more. Astronomically, a lot more is what you sometimes see with CEOs, depending on the company. So where's a 1 on this graph? It'd be somewhere way out here next to the 0. And notice, if we look at this graph a little bit closer, let's say that that's 500. This is going to be about 240. So there's a range from 0 to 240 going that way. And the vertical direction, we have something called frequency. It goes from 0 to about, on this rectangle, let's call this 275. So when we look at this histogram right here, I'm going to focus on just this rectangle. Any questions so far? Okay, so what this rectangle is finally saying is, let's look along the axis. We're going between 0 to 240, and that's going to be the ratio right here. Sorry, I have to scroll back to bring it where it was. That's the ratio of the worker pay. Now the height is the amount of companies that where this occurred, 275 companies. So let's write down a really quick blurb. There are 275 companies where I'll just say the ratio between the CEO and median worker is between 0 and 240. Okay, so that's what this rectangle right here says so far. Does that make sense at the moment? Okay, so if we took a sample of all these companies, 275 companies in that sample are going to have the CEO being paid, well, if it's a 1, roughly the same as the median worker, all the way to 240 times as much as their median worker, which is, again, quite a lot. If we keep on looking at this histogram, notice there's some blips way out here. I don't know how high that rectangle is. It's really short, but there are some companies where the CEO makes 1,500 times as much as the typical worker. It gets even worse. There's some stuff way out here on the 2000s as well. And so it just keeps on going higher and higher and higher on this thing. But essentially, that's what a histogram is. We have loads and loads of observations from these companies, and we're just putting them all together in a graph like this to see where does the data fall. Most companies are between 0 and 240 in the rate of CEO to median worker. and then it falls off very, very quickly. Any questions at all about that histogram so far? Okay, let me take a screenshot of this. And let's put it in our current notes right here in section 2.1. Or 2.1, maybe how about, sorry, just trying to find a spot to drop it in. Maybe down here, right after this. That might be a good location. So if you're reading about why did we select a histogram, what in the world is a histogram, here's one right here. I guess it could really use a title too, right? This is a histogram. Okay, so back to the table. That's about what a histogram would look like. They look very similar to bar charts, but the only difference now is if you had a bona fide bar chart, there's gaps between every one of these rectangles, and there won't be numbers, there'd be descriptions like I color yellow, I color blue, and so on. The actual categories from the categorical variable would be the labels on the horizontal axis. But the data is numeric, we'll just put the numeric values along the horizontal axis and sort how many observations belong to each one of these rectangles. Well, other questions, folks, before example 3? Okay, let's give it a try then. In example 3, we have different scenarios that are occurring here, and we're deciding if we receive the data for each one of these scenarios, how should we best display it? Should we use a bar chart or should we use a histogram? So we'll focus on just those two. Let's do green for histogram and blue for bar chart. And part A says, we're doing a study, and all we're going to do in the study is make a record of gender of selected individuals. So in that case, we're expecting to see things like male or female, but this study is going to put in 0 for male, 1 for female. So now we have to decide, what display should we use? Is this going to be a bar chart, or are we going to use a histogram for these data? So it's definitely kind of tricky, I think. I agree with the bar chart on this one. We can say here, if we're just recording gender as male and female, that's categorical data, it's going to be a bar chart. And if we decide to use coding symbols like 0s and 1s, as some studies do, it's still categorical. We're putting people in a category for 0 for male, category 1 for female. And so this whole thing would be bar chart. We do have to explain our choices as indicated here, but when I say briefly explain, that's a one way to give almost a hint. It's going to be an extremely fast explanation. You probably don't even need a complete sentence. So for me, the explanation would be, since the data is categorical. So categorical data, a bar chart, many other displays such as bar charts, pie charts would be great. Our book is going to focus mainly on this one here. Does that make sense to folks so far? Okay, so we look at the scenario, decide on the kind of data we're getting. We say categorical, all we did is we selected that display here. Now on the next one, it says, we're doing a study and we have a record of the age of the selected parents in years at the birth of their first child. So this is going to be numeric. Would you all agree? Awesome. It's debatable if it's numeric continuous versus numeric discrete, but that's not really the thrust of this question. Whether it's discrete or continuous, we would still be using a histogram because of it being numeric data. So less of a worry there. We'll just say histogram, since, let's say this even more brief, this is numeric. So numeric data, there's lots of displays for that one as well. But the histogram plays a very special role in statistics. We'll see later on in the course. Well, next, I'll leave this one to the class. Part C is going to record the height of selected individuals in inches. Any volunteers for the best display? Yeah, go ahead.
So histogram.
Exactly. We'll go histogram. since it's numeric data. And let's maybe, it's not part of the question, so I'm going to put this in orange, just as a reminder. We know it's numeric, but on this one, would you say numeric continuous, numeric discrete if you had to? I agree with continuous on this one. Here we're making a measurement. We're calculating the height in inches, and that changes on a continuous scale. It doesn't jump in discrete values. So we could say here, because of the measurement, it is numeric continuous. I want to also mention that if you come back, look at these notes again, my goal is to make it so that it's not so busy, it's not so crammed, you can't tell what in the world happened. And part of the reason for the colors is that exactly. If you see anything in orange, it was just a side comment. Wasn't required to answer the question, wasn't required for full credit, just a part of class discussion or a side comment we addressed. Now, next on part D, we have a record of blood type of selected individuals, just record as A, B, or O. So no rhesus factors on that. But if that's all we're getting, a bunch of A's or ABs or B's or O's, would you all agree that has to be categorical?
Yeah.
Awesome. So since it's categorical, we would select the bar chart right up here. So bar chart. Since it's categorical. So, well, looks like we did it, folks. The purpose of section 2.1 is selecting the right display, which is what happens in example 3. But it was more about what is a continuous variable, what's a numerical variable, how can you tell if you have something like an example 3, where it's just descriptions, or how can you tell if it looks like this and you actually see some of the actual data as well. So those are the major takeaways. And with what we'll be doing in the next sections is producing some of these displays. We're going to create bar charts, dot plots, and box plots. The one thing we won't create, sorry about this, is we're not going to create the histograms. Not because it's a bad endeavor, it's because it's computationally intensive to create that by hand. It's so computationally intensive that if you need a histogram, the best advice I can give you is use technology to create the histogram. So whenever a histogram is needed for us, I'll have it printed out like this right here. Our course is not going to focus too much on producing those kinds of graphics. It'll be more about reading and understanding them. Does that make sense to folks? Awesome. Well, let's save this up and now go to the next section. So again, the sections in this book are a little bit weird. Sometimes they're short and sweet. We wrap them up even as little as 25 minutes. Other times they could take multiple days, like section 2.1. So with what's coming up ahead, this is a really short section, 2.2. We're going to look at construction of bar charts. And section 2.3, that's the long one. We'll be looking at the dot plots and the histograms in that section. So now for the moment, let's run off to 2.2. And I highlighted one portion of these notes. Bar charts right here. This actually had a little bit of a longer title, other things like comparative bar charts and such. In your reading, if you just focus on the bar charts, that's going to be the main takeaway. That's where the problems will come from in WebAssign, as well as quizzes and exams. So first thing we have to take a look at is the so-called frequency distribution for categorical data. So recall, whenever you have categorical data, you're looking at just names of things. Even if they're numbers, they function as some kind of title or name. And we need to know how many times do those things actually occur. For a really fast example, let's take a look at the top of 2.1. The age of data here was the categorical variable. Let me scroll down to maybe this one that looks more readable. So in that categorical variable, frequency distribution would tell you how many times did year-old occur, how many times did recent occur. It's not really going to tell us when we look at the listing, but the frequency distribution will give us exactly that. So the frequency distribution is really helpful. We're going to need that to create our graphics. And what we mean by frequency is just the number of times an outcome like recent data, year-old data actually occurred. Any questions so far? Okay, I forget I actually have a table down here. I'm going to paste it here just temporarily while we're looking at these things. So here's a nice frequency distribution right here. I have a categorical variable we're going to take a look at. And the outcomes are these titles here for previous ownership of a car. So American car, Japanese car, and so on. The frequency here tells us the category, here are those categories, and the number of times the category appears in the data. So 760 American cars, 375 Japanese cars, and so on. So from this table right here, that's where we're going to construct our graphics in a moment. But before we do that, let's actually see what our data even is. Don't forget, deleting a table is a whole process in Microsoft Word. So I'm going to leave relative frequency hanging for the moment, and let's take a look at example 1 first. So here's this setup. An automobile marketing firm, imagine you're the one in charge of that firm, conducts a study to see what types of cars people owned before buying an American car. To me, that's kind of a confusing statement. Let me highlight this. What type of car do people own before buying an American car? So imagine you're at a car dealership, you're trying to sell people some kind of American car, maybe a Ford something. If you see what they came in rolling in with to buy their new car, and it was already an American car, that might be advantageous information for you. If you're trying to sell American cars on your lot, maybe you have a great used one, they're trying to just eliminate this month really, really badly. You see someone coming in with maybe a German car. You might think, well, I need to change my marketing strategy because, well, that might be kind of rare for someone to buy an American car when their previous ownership was a German car. Maybe not for everybody, but there might be reasons for that. Does that make sense so far, folks, on the context at the moment? Okay, and just to add a little bit more to that, the direction I'm going with the previous ownership and how it influences what car you might be able to sell to that person. Suppose you're trying to sell an American car to somebody who has maybe a Japanese car or a German car. Those cars are known for being highly, highly reliable, and that person might be a fan of those cars. You might instead pivot and try to sell them maybe another Japanese car, maybe another 4Runner or something like that. They might want that car. They come in with a BMW, you might not show them the Ford Escorts, you might show them some other cars along those lines instead. So that's what this data is. And now it says, see the Excel file titled example1 dataset. I don't do this very often, but occasionally our data sets are so large, I just can't even put them in the notes. This is one of those times. So let's go to the Moodle website. It's referring to this file right here, example1 dataset. Not something you'd want to print, but let's open it up. And here's what the data looks like. So again, imagine you are in charge of that marketing firm. You're watching people come into a car dealership, and the moment they do buy an American car, you're just recording what car they had prior, their previous car. So this column right here, this one is not even a variable. That's the identifier, and we're just identifying them by subject numbers. This right here, that's the categorical variable. It has several outcomes, American car, Japanese car, and so on. And so if we just select a row at random, let's just scroll, then say that person 515 bought an American car, and they prior had American car themselves. Does that make sense to folks at the moment? Okay, we go to other random rows, scrolling through here. Let's see, this person had a Korean car, maybe a Kia or something like that. Another thing you might have noticed is if you yourself are in charge of the marketing firm You have a lot of data from the study. That's terrific. There is 1,268 observations. But what do we know about this data really? Just based off the raw file. It's kind of limited, right? I can't tell you even how many outcomes there are just looking through this file. It's way too big. Maybe the only thing I could tell you if I scroll through this is, seems to be a lot of American cars. That's about it. I can't tell you, well, how many Japanese cars are there relative to American cars? So in some sense, after you collect the data, like what we see here, this data is kind of meaningless until we have some graphics to go along with it. Would you all agree with that? Meaningless might be harsh, but it's really hard to work with. And if you are the person in charge of that marketing firm and you go to the dealership, you can't give a presentation based off these data. Your firm is going to be fired, never to be used again, probably blacklisted. You have to bring more to that discussion, right? And what they would say in a marketing meeting is, where are my graphs? A picture is worth 1,000 words. So we have to fix all this. But first, let's pause on part A. I think I might have stole some of that question. Sorry about that. It says, if the marketing firm were to make any decisions with this data set, what practical difficulties would they face? Well, with what we were discussing, we can say briefly here, it is almost impossible to understand a data set such as this without a graphical display. We have no sense of what the categories even are and how many times they occur. In other words, if we want a graphical display, we first need to come up with frequency distribution for that categorical data. And I saved everyone the trouble. You would have to go here, count the number of times American cars occur. Excel is amazing. You can make that automated. Count the number of times the Japanese cars occurs and so on. And it produces this table like we see right here in part B. I'll never make you do that. That's way too much work. But at least we have a frequency table right here. So now, at least with the frequency table, I can see, yes, there were loads and loads of American cars. What I would have never known is there's almost half as many as Japanese cars. I would have thought that there's hardly any Japanese as well when I was scrolling through all those files. I think I did see Korean, German, but I don't think my eye even spotted that there's even other cars that's all glommed into the label of other. Maybe they're European cars like Alfa Romeo or something weird like that. So we have a nice table here. And what it's asking us to do is calculate the relative frequency distribution for these data. Well, let's get started with that. Maybe first, let's take a look at the definition, because although this data table is helpful, it still is missing one little thing. I don't necessarily know what percentage of cars are Korean, right? And that would be really good information. I don't know what percentage of cars are Japanese. That's also really, really good information. And that's what the relative frequency table is going to give us. What we do is, for each category, take the frequency. We have our frequencies right here. Divide by the number of observations in the data set. That's going to be the sample size, which we use as lowercase n. And we're converting these all into relative frequencies. They're essentially percentages written in decimal form. So we'll know a little bit more information if we provide that. So let's give that a try. Any questions or comments first? Okay, so we are essentially giving percentages in decimal form is essentially what this formula is saying. And the first place I would start with this would be right here. The number of observations in the, oh dear, let me try this again. Data set, there is a misspelling there. There we go, can't let that stand. This is the sample size, n. So that would be the first thing I'd want to calculate. What is the sample size in our study? If you looked at the data table, you could just say scroll all the way to the bottom, and it's 1,268. So that's a great way to do it. Watch out for this 1269. That's off by 1 because my first row included a title, subject, and previously owned car. So that's a fair way to go. I think what you would normally do on a quiz or an exam problem is just tally what you see here. Let's do it that way, just for the heck of it. One thing I mentioned in class is every time we have to use any kind of calculator, I'll duplicate it right here. Here's the TID4, the recommended calculator for the class. And I'm not doing anything fancy, but it's good to kind of introduce ourselves to the calculator sooner rather than later. We'll start using it more in earnest beginning in chapter 3. So if I want to tally all this, first thing I would do is just start typing and going. Take 760, add to it 375, then add down the row. What's nice about these calculators is you could just put everything in one shot and hit enter. So now plus 72, plus 37, finally plus the last category, 24 observations. The little arrow here on the left is just telling us what we started typing is now cut up on the left. If you had to change it or revise, this arrow pad can take you all the way to the beginning or all the way to the end. But let's just hit enter. And 1268 is what we're expecting for our altogether sample size. So let me write here, just as a reminder, n equals 1268. Does that look right to folks so far? Okay, well, back to the calculator. Let's now crank all of these things out. Now, the calculator is really helpful for us, but once we get into chapter 3 and beyond, it's still kind of tricky. The smallest mistake I make right here is very, very noticeable by WebAssign, unfortunately. So my best advice of the calculator, I'll repeat this a lot, is go a little bit slower and you will absolutely save a lot of time, which is weird, but that's how it kind of works in statistics. And if you see me type in anything incorrectly, just feel free to yell out at any point, oh, you have a typo or something like that, and I'll fix it immediately. So now for relative frequency, we take a look at the formula. It just says, take your frequency value. So I'm going to go entry by entry, starting with 760. Then divide by the number of observations. That's going to be 1268 for all of them. So hit the division key, 1268. And here's my first value right here. Now, that's kind of annoying. I would say if you see digits like this, rounding is probably going to happen. Now, try to always remember to include it in the actual problem itself. We're going to go for 4 decimal places. Now, for me, I'm not really super picky on rounding. If you gave me 0.5993, that's okay in my book. Not WebAssign. They're going to know it wasn't rounded correctly, so that's something they do bug you on. If you're ever doing a numerical problem in WebAssign and they just keep giving you issues like that, click on the Ask My Teacher button. And if it was rounding, I'll tell you the right answer rounded correctly. Yeah, go ahead.
So when rounding like that, will be rounded to the 0.6 or 0.9?
It'd be 0.5994 altogether.
So is it like 40?
Exactly. When it's said to 4 decimal places, we're looking at this one first to start out on the 4th place. And then we compare on the 6 right here. Because it's larger, it means the 3 has to round up. Larger than 5, rather. If it was below 5, we would have kept it 0.5993. Kind of irritating, honestly. But it's something that WebAssign, it's an option I can't really control. We do have to be particular about rounding. Only in WebAssign. And again, if you put in your number, you felt like everything was right, it might be a round issue. Just hit the Ask My Teacher button, and I'm not opposed to just giving you the correct rounded value if I can tell that is essentially all that was wrong. Does that make sense to folks so far? Okay, let me record this as 0.5994. So that's 1 down, and we're well on our way. That's kind of the purpose of us doing the calculator in class. With statistics and using WebAssign, they're very particular about their numerical values. So I'll always give you strategies and hints as we do them in class. So let's try this again. We need relative frequency for the Japanese cars. So first start with frequency, 375, matching that formula above. Then divide by 1268. That's the denominator, number of observations. And we need to be really careful about this stuff. So let's be really careful on this one as well. Fourth decimal place is the 7. Value right after is a 4. So this one rounds to 0.2957 to 4 places. Does that sound about right to folks? Awesome. Let me throw that in. 0.2957. And then rinse and repeat. We'll do lots of computations. And so we'll get pretty fluent with the calculator after lots of practice. And let me do one extra thing for the notes. Let me highlight that in yellow just to match up number of observations here with a sample size n we indicated. So down the row, next it's 72. Divide by 1268. Double checking the numbers. We have fourth place is 7. Value just after is 8. So this rounds up to 0.0568. Oh, let me get that back in there. 0.0568. Now let's keep on going. One thing I want to also mention the calculator is there is a huge amount of shortcuts. Some of them actually make quite a bit of difference later on in class. And even right now, you can save some time on this kind of stuff. For example, if you want to do the next row, and you know you're always divided by 1268, you can hit on your calculator the second key. Come down here, hit the enter key. Above in blue is where it says entry, meaning we're just putting in our prior entry. It pulls up what we just calculated. At the left arrow, you can move over to the left and put in a 37. Now, that didn't save a lot of time, but I assure you, there's going to be times in this class where we put in a bunch of stuff into the calculator. We're changing one thing, a plus sign to a minus sign right in the middle. That trick right there could save you 30 seconds on each one of those kinds of problems, which could make a big difference in the end. So this one then comes out as a 0.0291. Next digit is a 7, so we'll round it to 0.0292. 0.0292, and last one. I'll show that trick again in case you're curious. It's not too valuable now, but it will be later. Hit the second and entry, and it calls up that last value. But there's another way to do this. You can also just go up arrow. Highlight this, hit enter, and now use the left arrow and put in 24. So if you like the arrows better, that's a great way to go as well, the up and down arrows. I'll hit enter here, and this is my next output. The fourth decimal place is a 9, right after is a 2. So this becomes 0.0189. 0.0189 down here. Well, it looks like we got it, folks. That's the relative frequency. Any questions at all in calculating that thing so far? Okay, that's a lot of computation. And again, with WebAssign, it's good to go a little bit slower to save potentially a good amount of time. Here's the next thing I'd probably do. Let's say this is a WebAssign problem. Maybe it's on my fourth attempt, and I want to make real sure it's correct. You could hit the Ask My Teacher button if it's your final attempt and you just want to make sure you have good guidance on it. Or you could do a check here. Can anyone guess what the check might be for relative frequency if they're essentially percents? Yeah, go ahead. Exactly. So if we say are right here on maybe the Japanese, multiply that by 100 and it's saying 29.5% were Japanese cars, or roughly 30%. So every one of these is giving you good information on just what's happening here. As far as percentages go, it was almost 60% American cars, about 30% Japanese, a little over 5.5% for Korean. And I could have never told anyone that if, once again, we're just scrolling wildly through this. Although it's precise data, it's meaningless if you cannot paraphrase it in some way. Does that make sense so far? Awesome. And last thing we can do with this one is, if we're worried about the numbers, these numbers here, because they're percents written in decimal form, they should sum to approximately 1. Let's add that as a remark here. These should add up to approximately 1. Now, if we did 0 rounding whatsoever, that would have been exactly 1. But we round to the 4th decimal place, so I'm expecting something like 0.9996 maybe, or maybe by the fluke of rounding, it does come out as exactly 1. As long as it's very, very close, we'll say that this is likely correct. So I honestly have no idea. Let's see how we did punching those in. So I'm just going to type in all those numbers, 0.5994 plus 0.2957 plus 0.0568 plus 0.0292. Last one, plus 0.0189. I went kind of uncarefully. I might have missed keyed a digit. Let's see how close all that came in. Hey, I got exactly 1 on there. So it sounds like if you get exactly 1, you're in business. The rounding was precise enough. So by a fluke of the rounding, it came out exactly 1. But if a different problem, again, it was like 0.998, you're still very likely absolutely correct on your answers there. So now we've got pretty much everything we would like to have right before constructing a bar chart for this data. Any questions at all, folks, on filling out relative frequency? Okay, so all this so we can understand a very large data set. I'm noticing on this question, I did leave one thing off. It says construct a bar chart for these data. Well, there's 2 kinds of bar charts you can construct. One bar chart would use previous ownership and the frequency values. That's a great bar chart. You're comparing the relative size of all the categories against each other. But some people, if they prefer percentages, they might use this instead. And they're both equally valid. They're both going to look the same. The only thing that differs is the vertical axis. But I should have in my instructions indicated one or another. So let me put here, construct a bar chart for this data using relative frequency. Let me put that in red because that was a correction right in the middle. Well, that's what we want to do very next, but I'm kind of noticing we have less than 2 minutes. Yeah, that would definitely be a rush job. So we might have to come back next class and finish out our bar chart. Any questions at the moment? Okay, so we'll finish off these notes here when we come back next class. Again, this is a really short section, same as in WebAssign. And then we'll be in section 2.3 as well next class. Well, have a great night, folks. If you have questions, I'm available down here. I don't have a class right after this one. Otherwise, I'll see you all on Wednesday. Camille Coxon? Okay. If you hear me calling names randomly at the end, I'm just trying to hand back papers, so no worries. Hey,
Okay, so my web, it'll only show me this, it won't show me your assignments.
oh, so
Cause I didn't buy my book through.
there should be a way to just get complimentary access, however.
Okay,
So let's
yeah,
see
because
what it
I'm
looks like.
renting my books through like Amazon, so.
Gotcha. What happens if you click on, say, maybe the math 1153-10? Oh, geez. How
Yeah,
about
so
very bottom?
do we have assignments? I'm not sure.
Do you mind if I just click
Oh,
around there,
go
see if
for
I
it.
can find what's going on?
And I'm pretty sure that, another student has had this issue.
Okay, thank you for letting me
Yeah.
know. So my home. Oh, there it goes, it's just slow. And now, let's see here.
I'm just super bad at technology, so I probably wouldn't know what to do anyways.
And WebAssign has a way to be. For temporary access expired. Access ends 8/28. Oh, I think it might have just been the complimentary access already
Oh,
ran out.
okay.
It's supposed to be 2 weeks of access. Do you remember when you first started it?
On the first day of school.
Gotcha. It's kind of odd. So yeah, first day of school, that hasn't been 2 weeks for sure. I'm gonna have to make a note about that. So yeah, when you first register here, they're
Mhm.
supposed to give you 2 weeks
Yeah,
of complimentary
yeah.
access, but somehow yours is ran out right away. What I'll have to do is take a message to the Cengage folks that are controlling this and see
Okay.
if they can give me any information on what in the heck is going on there with that.
Okay.
So can I take down your name just so
Oh,
I
yeah,
can
it's
correspond with you?
Isabel Kelly.
Gotcha. With
And
a
then-
Z?
And I'm assuming we have assignments this week.
Yeah,
Okay,
but the good news with the assignments is you can extend the due dates. too.
Okay.
So there won't be any credit lost for technology issues.
okay, good.
So Isabel Kelly, you said you heard some other student might have found.
Yeah, Jackson, I don't know his last name.
Gotcha. So I'll correspond with him as well, and let me just put here, 2-week access
And then do I
expired.
request an extension on WebAssign?
Yeah, it would be an
Okay.
extension through WebAssign, and I can show you what that would look like if you're curious.
I think I remember, I think you showed this yesterday, so I think I
Okay.
should remember, but,
Yeah.
okay,
So I'm gonna send them an email probably tomorrow morning, first
Okay.
thing, and go from there to try to figure it out.
thank you.
Yeah, you bet. Sorry for the frustration with that there. Yeah. Any questions?
Just since you like don't have another class, I was
Mhm.
wondering if you could, this question, like, I get it like more after you were talking about like there's no control group,
Yeah.
but I was wondering if you could just like go through this and tell me like how
What
you
comes
personally
out?
would think through it.
Yeah, absolutely. So let me pull that open. And quiz one. Quiz one right here. Okay, let's take a look. It says, although there's popular belief that the herbal remedies such as ginkgo biloba may improve learning and memory in healthy adults, these effects are usually not supported by well-controlled research. Okay, that's kind of just fluff, right? They're just telling us what the context will be. Now it says in a typical study, a researcher has a sample of 36 participants. Here's where it's getting interesting. And has each person take the herbal supplement ginkgo biloba every day for 90 days. At the end of the 90 days, each person takes a standardized memory test. For the general population, it's believed the mean score is 80 points, but for the 36, the sample mean was 84 points. Okay, so that'd be how I probably much start, read through the context in this way. And then I highlighted things that were really kind of popping out at me. I would say here, there's 36 participants. All took ginkgo biloba. So what that means is there wasn't multiple treatment groups. So I would say next, there was not multiple treatment groups. Then the thought I would have in my head, but I probably wouldn't write is I would think, well, if there's not multiple treatment groups, it's not an experiment. And so I write, this is an observation. Or this is observational. But that would probably, even though you didn't necessarily have to write it, it might be a good idea to say here, this means it's not an experiment. Simply because it has to have more than one group for an experiment.
Okay, so the group that is taking the supplement, that is a treatment group, right? Still, but it's like not, since there's not more than one, it's observational.
Exactly. We'd have to have split up those 36 participants into different settings, essentially.
Okay, so then if they did like, so if they split them in half and then like half of the group was on a placebo, then that would be an experiment.
Exactly, yeah.
Okay.
The placebo people, we'd look at their memory test score and we compare it against the ginkgo biloba people and see who just did better or if it's about the same.